So in this video, we're going to go through the hydrolysis of an acetal, which is essentially the reverse of the acetal formation reaction that I covered in the previous video. What I'd like you to do is watch both of these videos and pick out the similarities of the reactions between all of them. All right, so our first step to hydrolyze this acetal is to figure out what the nucleophile is. In this case, I need to destroy the acetal in some way. So the acetal needs to be protonated in order to start to look like the alcohol. I need to put a hydrogen on there. So that first step is going to be a proton transfer. And that proton is going to transfer right to the ether. And what I'm going to wind up getting is the protonated ether. Okay, the next step is going to be the elimination of that first alcohol. So these electrons can come in and help push out the alcohol. So the second step is going to be elimination of the alcohol. Okay. So what I get from this is this positively charged compound, as well as the alcohol, which has eliminated from this. Okay, so this is an activated carbonyl. I have the carbonyl with the positive charge on the oxygen, and I got an alkyl group on here. And here's where water starts to come into play to act as a nucleophile. If I were to add the alcohol back in, I'd go right back to the acetal. We're trying to hydrolyze it, so the more water I have present, the more it's going to want to react with the water. And this will be addition of water. So step 3, addition of water. So that's a nucleophilic attack. And what I wind up with in this case is the ether and water having attacked here. Okay, so now I need to transfer the proton because I need to get that other alcohol to eliminate. I've eliminated the first one. I don't want water to eliminate. I want to add water to this to get back to the carbonyl. So I need to do some proton transfers. I have a lot of water in this reaction, so I'm going to use water as the nucleophile to take off the hydrogen. All right. So again, we're just going to call this a proton transfer. I'm taking the proton off in this one. So there's a proton transfer. And that'll give me the OH here and the ether. And now I'm going to deliver that from this protonated water. I'm going to deliver it back to the molecule, but at the ether stage. So the ether is going to act as the nucleophile, attack, and I'm going to eliminate water there. So again, step 5 is another proton transfer. And what I'm going to get from that is the OH. And I have the ether, which is positively charged. Now we're set up to eliminate that alcohol. So the next step is an elimination of the ROH, of the alcohol. Call that step 6. And that's going to be assisted by the lone pair here. So we're going to push and kick off the ether. What that does is that'll form a protonated carbonyl. And that'll give me the alcohol as a leaving group. And since I have a lot of water around in this, I'm going to use that to take off that last hydrogen. So again, this will be a proton transfer. That will eliminate the hydrogen. And what that's going to give me is the ketone. And you can see that I have eliminated 2 molecules of the alcohol. I've eliminated one over here. I've eliminated the second one over here in this step. All right, that's why we have 2 alcohols that have been eliminated. So again, I'd like you all to go through this mechanism. Make sure that you understand the steps. Let's call this step 7. That was a proton transfer, just to remove it. You should be able to work these mechanisms backwards and forwards and understand the intermediates along the way.